Hey, it's Doc Williams, and in this video, we're going to calculate Kc, which is the equilibrium constant for concentrations, and Kp, the equilibrium constant for partial pressure. This question asks us to calculate Kc for the following reaction for the concentrations of NO3 equaling 2.00 times 10 to the negative 2 molar, NO equaling 1.51 times 10 to the negative 2 molar, and NO2 equaling 8.75 times 10 to the negative 2 molar. Then it asks which direction is the reaction proceeding. The first thing we want to do is write our equation for Kc, which will be the same way we wrote the equation for Keq. If you want a quick review of that, I'll link that video in the comments. So the equation for Kc will be the concentration of NO2 raised to the second power, and the second power is the coefficient. So anytime you have a coefficient, that will become the exponent. And the brackets mean concentration. And this will be over the concentrations of the reactants, which is NO3 times NO. Now that we have our equilibrium equation, we're going to plug in the concentrations given to us in the problem. So the concentration of NO2 is 8.75 times 10 to the negative 2 molar, and this is squared. And the concentration of NO3 is 2.00 times 10 to the negative 2 molar. And since there was a coefficient of 1, we do not need to write that. It's understood to be 1. And the concentration of NO is 1.51 times 10 to the negative 2 molar. When entering this into your calculator, I strongly recommend using parentheses wherever appropriate, because if you don't, your calculator will not do PEMDAS in the correct order. Reporting this to 3 sig figs gives Kc to be 25.4. This is the answer to part A. Now, part B asks us to determine which direction the reaction is proceeding. Now, when determining the direction, you want to look at the quotient. If the quotient is greater than 1, meaning in this case, Kc, that means you have more products than reactants. And if we remember from Le Chatelier's principle, when you have more products, the reaction will shift in the reverse direction toward the reactants. So we would shift left, and it will favor the reverse direction. If the quotient is less than 1, then we have more reactants than products. And this means that the reaction will shift to the right from the reactants to the products and favor the forward direction. So for the second part, which is B, this first part was A, it asks which direction is the reaction proceeding. Since Kc is 25.4, which is greater than 1, then we have more products than reactants, and that means that our reaction is shifting from the products to the reactants, and it is shifting to the left, favoring the reverse direction. The second question asks, what is the value of Kp if the following reaction mixture at equilibrium contains the partial pressures of CH4 equaling 1.5 atmosphere, CO2 equaling 0.159 atmosphere, and H2O equaling 0.260 atmosphere. The equation for Kp will follow the same guidelines as Keq and Kc, where our products are on top. The partial pressure of CO2 times the partial pressure of H2O. And we must square the partial pressure of H2O because we have a coefficient of 2. And if you notice, I did not include copper into our equation because copper is in a solid state. We do not include solids or liquids. We only include gases and aqueous states in our equilibrium constant expressions. So that will be all for our products. Now let's write our reactants. Now, since CuO is in a solid state, we do not include that. We only have the partial pressure for CH4. And since the coefficient is not seen, it's understood to be 1, is raised to the first power. Now let's plug in the partial pressures given to us in the problem. The partial pressure for CO2 is 0.159 atmosphere. And for H2O, is 0.260 atmospheres squared. And this is over the partial pressure for CH4, which is 1.50 atmosphere. This gives a Kp value of 0.00717 atmospheres to three significant figures, or 7.17 times 10 to the negative 3 atmosphere. This next problem is a KC with two parts. The first part is asking you to calculate the value of KC, and the second part is asking the direction that the reaction is proceeding. Pause the video and work through solving for the value of KC, then determining which direction is proceeding. The equation for KC will be NH3 raised to the second power over N2 and H2 raised to the third. Since it's asking us to find Kc, we're finding the concentration, so we're using the brackets. And remember, our products go at the top, raised to the power of the coefficient, and then our reactants go at the bottom, each one raised to the power of the coefficients. And since all of these are gases, all of these will be included in our expression. Now we just plug in the values that we have in the problem. For NH3, we have 0.720 molar squared. For N2 is 0.145 molar raised to the first power. And for H2, we have 0.234 molar raised to the third power. So the value of Kc is 65.3 to 3 sig figs. And since this is greater than 1, we have more products than we have reactants, meaning that the chemical reaction will shift from the products to the reactants, proceeding to the left, or favoring the reactants. If you found this video helpful, please hit like and hit subscribe to know when more videos are posted. And as always, thank you for watching.